Alright, good morning, ladies and gents. I come to you from my kitchen. We're going to go ahead and we're going to get started today with some notes. You'll notice I put a divider line right under my last bit of notes where we were talking about how to multiply and divide integers. Today we're going to be talking about exponents, and I've also put today's date off in the corner. So when we're talking about exponents, I'm going to give you an example here, and I'm going to put it right in the middle underneath where I just wrote my header. And let's do 4 to the 5th power. That's how we read this. We always read this as the base number 4 to the 5th power. So this is what a power is going to look like. Now if you have with you, I'm just going to bring mine over here, some highlighters. You're going to want to go ahead and grab those. If you don't, you can use different colored pencils, you can use different colored pens, entirely up to you. I happen to have 3 highlighters, so that's what I'm going to use. So the entire thing, I'm going to draw a box around it. The entire thing with both numbers together, we call this a power. And I'm going to grab one of my highlighters, doesn't matter what color you have, and I'm going to highlight the whole box around it, and then the word power, because that tells me the whole thing is called the power. Okay? So each of these numbers within the power also have their own names. This one here, and I'm just going to draw an arrow coming down from the 4, the bigger of the two numbers we call the base. And again, I'm going to grab a highlighter, highlight, and then the word base. Ooh, that got a little smudgy. That's okay. Okay, the smaller of the two numbers, this is in superscript. If it's written down below, we call it subscript. If it's written up above, we call it superscript. But at any rate, this is the actual exponent. And I'll grab my last color. Hopefully it doesn't smudge up that bad this time. I'm going to outline my 5 and the word exponent. Not too bad, not too bad. Okay. And then the next thing we're going to write is the actual definition of what a power is. Remember, power is the entire thing with, turned a little bit, sorry there guys, with both the base and the exponent together. So a power is made of a base and an exponent. Okay, I'm going to put a semicolon, and then I'm going to write this. It is a condensed, C-O-N-D-E-N-S-E-D, condensed way to write repeated multiplication. I'm just going to abbreviate that word multiplication. You may do the same as well. Let me move that down a bit. So it's made of a base and an exponent, and it's a way to write it's a condensed way to write a repeated multiplication sentence of the same number. And if you would like to put the hash mark in place of the word number, you are welcome to. So we're going to get to condensed way in just a second. There are 3 ways that we can write an exponent. The first way is called the exponential form. Exponential form. And I want you to notice it has the word exponent right in it. When you see exponential form with exponent, you know that it has to look like this. So I'll use our example that we had up at the top, 4 to the 5th power. Okay, this is exponential form because I can actually see the exponent. Okay, there's a hint. What kind of form they're looking for? Exponential, looking for the exponent. Then we have something called the factored form, or this is also sometimes called the expanded form. But I think for our purposes, we're just going to call it the factored form. Factored form. Okay. Now this is where we get into what is actually happening within an exponent. So you'll notice the two numbers in exponential form. We have the base number and the actual exponent. What this means, and when I say condensed way to write repeated multiplication, is like this. Whatever the base is, it's going to be that number times itself, however many times the exponent is telling me to do. So in this case, I have 4, and the exponent is telling me to multiply 4 by itself 5 times. So if I was going to write this out in factored form, it would look like this. 4 times 4 times 4 times 4 times 4. Okay? I see the base number 4, and I see it 1, 2, 3, 4, 5 times. Okay? So these two things represent the same amount, but they're just written in different ways. Okay? And now there's one other way to write it, and that is called the standard form. Okay? And this is just a way that says to evaluate. Evaluate. Okay? You might notice in the word evaluate, you see the word value. That means figure out what 4 times 4 times 4 times 4 times 4 is. What is 4 to the 5th power as just one number? So you can go ahead and grab your calculators to help you with this. If you are using your phone like I am here right now, what you can do is this. Take your phone, flip it sideways, and then you get a lot more functions on your calculator. But here's what I'm going to do. I can do 4 times 4 times 4 times 4 times 4 times 4, and then I would get my answer. But there is actually an easier way to do it. We'll take a look at this button right here. You see that X with the Y? What I can do is hit 4, then that button, and then 5, and boom. I have my answer. Oh wait, let me double check that. I think my calculator was wrong. 4 to the 5th power. Ah, there we go. I think I hit an extra button there, guys. Sorry about that. So, 4, let me just show you that one more time. 4 to the 5th power is going to be 1024. So, 1024. Okay? So, each of these 4 things, 4 to the 5th power, 4 times 4 times 4 times 4 times 4, 1024, all represent the same amount. They're just written in 3 different ways. So what I'm going to do next, and I'm going to flip to a new page. If you guys have room on the bottom of the page where you're working, please feel free to use it. I just ran out of space, so I'm going to move to the top of a new one. Alright, and at the very top, I'm going to put a number 1, and I'm going to put right in exponential and standard form. I should say forms. There we go. Okay, so we're going to try a couple examples here. So let me write this out. 3 times 3 times 3 times 3 times 3. Okay. So I already have it in one of my forms. This is factored form. Alright, I can see the base number, and I can see how many times it's being multiplied by itself. What I want to do is write it in my other 2 forms, exponential and standard. So when you're writing it in exponential form, you're only going to have 2 numbers. You're going to have the base number, and however many times you multiplied it by itself. That would be your exponent. So I'm going to take a look here. 3 is my base number. That's the one I'm going to see repeated throughout the multiplication sentence. And I see it 1, 2, 3, 4, 5 times. So 5 is going to be my exponent. So this in exponential form is 3 to the 5th power. what I'm going to do next is write it in standard form. And what that means is figure out what 3 times 3 times 3 times 3 times 3 is. So again, you may head to your calculator, because I don't expect you to do this in your heads. However, if you wanted to, it is possible. When I do something like this, I tend to take it in pairs. So what I would do is I would do 3 times 3 first, which would be 9. I would do the next 3 by 3, which would also be 9. And put my little multiplication symbol. And then this one doesn't have a pair, so I would just write 3. Okay? Then I would combine these two numbers. 9 times 9, well, that would give me 81. And then times that 3 again. Now here you could hop into your calculator, but I'm going to use the distributive property of multiplication. Or sorry, the distributive property of multiplication over addition. Excuse me. So, I'm going to think of 81 as 80 plus 1. And then I will multiply by that 3. That way I can do it in my head and I don't even have to go to my calculator. So I'll think to myself, 3 times 80, well, that would give me 240. 3 times 1 would give me 3. So 3 times 81 is going to be 243. Now I will go ahead and check on my calculator just to make sure that I'm good. Calculator, there we go. Okay, so I'm going to use that same button again. 3 raised to the 5th power. And what do you know? 243. So that is correct. 243 is the standard form of that exponent. Let's try another one. Okay? This will be a long one. 2 times 2. Perfect. Lots of 2's. Okay. Now writing it in exponential form is the easier one because all you have to do is look at what the base is and see how many times you're multiplying that number by itself. So the base number is the one you see repeated throughout. So it's going to be 2. Okay? And then I'm going to look, well, how many times do I see that 2? 1, 2, 3, 4, 5, 6, 7, 8. Alright, so this is obviously 2 to the 8th power. But now we have to write it in standard form. So I need to figure out what all these 2's multiplied together are going to equal. Now again, you can take it out in pairs, or you can plug it in your calculator. I'm going to challenge you right now to do it in pairs, figure it out on your own, and then check it on your calculator. So I'm going to pause my video. I'd like you to do the same, figure this out, and then once you're ready, hit play, and we'll see if our answers match. Okay, so I went ahead and did this. So if you take a look here, I did this in pairs, just like I did the one above. And the first time I combined my pairs, I got 4s. I combined these 2, I got 4. I combined these 2, I got 4. And I did that for all of them. So then I had 4 4s. Well, then I went ahead and I combined those with multiplication, and I ended up with 2 16s. And then from there, I did do some multiplication off to the side, but I ended up with 256. So let's go ahead and see if that is correct. So I have my calculator. Let me clear that. So I have 2 raised to the 8th power, and look at that, 256. Awesome. All right, so this in standard form, 2, 5, 6. Nicely done. Let's try one more. This one's going to be a little bit different. 7 times 7 times 7, and I'm going to throw something else at you, times 8. Okay. Oops. Sorry there, guys. Alright. Now, you'll notice I have 2 different numbers going on here. When I am trying to write them in exponential form, I am not allowed to combine bases. Okay, I'm not allowed to combine these 7's with this 8. So I'm going to keep them separate for now. I'm going to ignore this 8 for just a moment. And I'm going to go ahead and figure out my 7's. Well, I see 7, so that obviously must be my base number. And I see it 1, 2, 3 times. Okay? Now this 8 here, 8 has to be my base. It's the number I see in the multiplication sentence, but I only see it one time. And believe it or not, that is the exponent, 1. Every number, every normal, regular, sitting by itself number that you see is actually secretly to the first power. So this would be the answer for exponential form. I see 7 3 times. I see 8 1 time. That's why the exponent is 1. Now when we go to evaluate this, here's what we're going to do. Alright, this one I will head over to the calculator for because I'm using some bigger numbers here. So I'm going to do 7 raised to the third power. Alright, that gives me 343. And then I'm going to multiply by 8 to the first power. And there you go, 2,744. 2,744. Okay? Just be careful when you're doing ones like these. You want to keep those bases separate. And even if you see a number by itself, it's always to the first. Always to the first power. Alright, so let's talk about some of those weird exponents, like to the first power. I'm just going to shift this up a little bit. I have a little space down here at the bottom, so I'm going to go ahead and use it. I'm going to put a 2, and I'm going to write special cases. Okay, just like that. And I'm going to put 2 notes in here that I would like you to copy as well. The first one is going to say this: any solitary, meaning by itself, any solitary number is to the first power. Okay? Just like the one we did above where we had 8 to the first power. Any solitary number is secretly to the first power. So for example, let's say I had 7. Just the number 7. And I wanted to write this in exponential form, so has an exponent. Well, I know it just looks like a 7, but any solitary number is secretly to the first power. So if I wanted to write this looking like an exponent, it would be 7 to the first. If I had, let's say, 11 to the first, or sorry, let me try again. If I had 11 and I wanted to write it as an exponent, it would be 11 to the first. There we go. Let's say I had, let's try this one. I'm going to go to the top of my new page. Let's try a big weird number here. If I had, I don't know, 37,000, and I wanted to write that as an exponent, well, that would be 37,000 to the first power. So any regular, normal, sitting by itself number that you see, you can write as an exponent. It would just be to the first power. Now we have another weird one that we're going to talk about. And this is, it might not make any sense at first, but I will show you. Any number to the 0 power is, take a guess about what I'm going to write. Any number to the 0 power, what do you think it's going to be? Take a pause and think about it. Any number to the 0 power is going to equal 1. I know, weird, right? I would have guessed 0 if I didn't know this rule, but it does make sense, and I will explain why. So let's use, here, let's do this. Let's say I had 4 to the third power. Well, we know if we were going to write that out in factored form as that long multiplication sentence, it would be 4 times 4 times 4. Right? If I had 4 to the second power, it would be the base number times itself twice. So 4 times 4. If I had 4 to the first power, well, that's just 1 4. Do you see how I'm condensing? I had 4 to the third, I had 1, 2, 3 of them. 4 to the second, 1, 2 of them. 4 to the first, just 1 of them. So why in the world is 4 to the 0, 1? That doesn't make sense. It's almost like I had 3, there were 1, 2, 3 of them. To the second power, I had 1, 2 of them. To the first power, I had 1 of them. Well, I run out of 4s. Why would it be 1? You have to go back to our identities. Think back to the identity property of multiplication. That told us any number times itself is 1. All of these 4s are secretly being multiplied by 1. All of these 4s are secretly being multiplied by 1. Even this 4 here is secretly being multiplied by 1. So, even though I've run out of 4s, 1, 2, 3, 1, 2, 1, even though all of them are gone, the 1 is still there. That 1 still remains. That's why anything to the 0 power equals 1. So let's try some examples of that. Let's go back to that 7 that we had. So if I had 7 to the 0 power, well, anything to the 0 power is 1. If I had negative 13 to the 0 power, well, again, that would be 1. If I had negative 4.21759 to the 0 power, yeah, it's a weird number. It's being raised to an exponent, but because that exponent is 0, it still equals 1. It still does. Any number raised to the 0 power will equal 1. Now there is only one exception. There's only one exception here. And here's the exception. If I raised 0 to the 0 power, well, he's the only person, the only number that isn't going to equal 1 when raised to the 0 power. That's going to be 0. But 0 raised to any power will be 0. So if I do 0 to the, I don't know, 92nd power, it would still be 0. Because no matter how many times I multiply 0 by itself, it's still going to come out 0. Okay? 1 kind of operates the same way. That'll be the other one that I talk about. If I had 1 to the first power, well, it doesn't matter how many times I multiply 1 by itself, it's still going to be 1. So 1 to the second power is the same as 1 to the third, is the same as 1 to the 10th, is the same as 1 to the 111th. These are all the same, because no matter how many times I multiply 1 by itself, it's still going to be 1. So these two guys here are the only exception to the rules. Alright, those two act really weird. Okay, they've kind of got their own set of rules. The last thing I'd like to talk about today has to do with negatives and exponents. Okay, and I'll show you what I mean. Negatives and exponents. Now, when I talk about negative, I'm talking about the base number. You can have the actual exponent being negative, but that's for a totally different day. So here's what I want to talk about. Let's say I'm going to show you two things. They're going to look similar. You might even think that they are the same. They are not the same. So I have negative 6 squared and then negative 6 squared. Now I said them slightly different because they are slightly different. And here's what I mean. Whenever I have an exponent, it only applies to what is directly underneath it. So for example, with this one here, squared only applies to the 6 that is directly underneath it. This negative is separate. So what happens is I have to do 6 squared. That one has its own name. Raised to the second power, we call it squared. 6 squared would be done as you would expect. And you'd get 36. But then this negative jumps down and joins them. Okay? So because the exponent only applies to what's directly underneath it, that negative gets hitched on at the end. Now this one, for example, is different. Those parentheses give this a different value because this exponent now applies to everything that is inside the parentheses. So it's not just 6 times 6 and then make it negative. It's negative 6 times negative 6. Now you might be saying, Miss R, what's the difference? Well, we know from multiplying our integers that whenever you have an even number of negative signs, what happens to your answer? It's going to become positive. So this is now going to actually be positive 36. Okay? If you see it with no parentheses, these guys are always negative. So let me put that here. Always negative. For these, if you see the parentheses, it depends. What do I mean by it depends? Well, let me do another example and I'll show you what I mean. So let's try this one. So let's say I had negative 7 to the third and negative 7 to the third. Okay. So I'm going to go ahead and evaluate both of these. So when I don't see the parentheses, I'm going to do this like normal, and then I'll make it negative at the end. So this would be, I see the base number is 7, and I'm multiplying it by itself 3 times. Okay, and if I remember correctly from a previous problem, that's going to equal 343, but you know what? I do want to double check on my calculator. So 7 raised to the third power. Yep, 343, I was right. So 343, and then we're going to grab this guy and stick him on. Okay. So that is negative, but these guys are always negative. And I said for these, it depends. So let's try this out. So remember, this to the third power applies to everything that's inside. That includes that negative sign. So this is really negative 7, the whole thing, times negative 7 times negative 7. So it's the whole thing times itself 3 times. So I know it's going to be 343 because it's 7, 7, and 7, but I need to pay attention to the number of negative signs that I see because I see 1, 2, 3 of them. Odd number of negative signs means that my answer is also negative. So what happened? Now it's a negative number. That's why I said it depends. Because depending on what, let me move back down to this one. Depending on what your exponent is, your answer could end up positive or it could end up negative. So you really need to watch and pay attention to those. So we're going to stop here. I'm going to have you guys hop into IXL, and you're going to do some practice there. Now, I've put a couple skills on there for you. If you master them, awesome. If you're having trouble, let me know. We can work through them together. But I'm not looking for mastery of each individual skill. I'm going to look for how much time you devoted to each one, and that's what I'm going to base, if I do any sort of grade with it, that's what I'm going to base my grade on. Alright guys, so Good luck on IXL. Let me know if you need help.